consider the 5 by 5 matrix A. It is given. It is given that A has only one real eigenvalue. He said that also. How many eigenvalues it may have? 5 values it may have, but it has only one real eigenvalue. It can have up to 5 eigenvalues. Only one real value. Out of 5, only one real value. Then the real eigenvalue of A is what we are find. This is one small property that we remember. We can solve that sum. If you add all these things together, what you will get? 5 plus 1, 6 multiplied by 5 divided by 2, 15. Here, if you add 1, 2, 3, 4, 5, 15. If you add this 1, 2, 3, 4, 5, 15. If you add this also 15. So now what we can do is, let us write to find characteristic polynomial. To eigenvalue, what we have to write? A minus lambda I modulus of A minus lambda I equal to 0. You can write lambda I minus A also. So what you will get if you write like that, determinant of lambda 1 minus lambda. You will get 1 minus lambda. The first value is 1 minus lambda. 1 minus lambda. 2, 3, 4, 5. So here what you will get? 5, 1 minus lambda, 2, 3, 4. Then you can write 4, 5, 1 minus lambda, 1, 2, 3. So here 3, 4, 5, 3, 4, 5, 1 minus lambda, and 2 you will get. The last row is start with 2, 3, 4, 5, 1 minus lambda. If we add all rows, all column elements, what I am going to write, the rule is C1 equal to C1 plus C2 plus C3 plus C4 plus C5. Then what you will get? 15 minus lambda, 2, 3, 4, 5. Here also you will get 15 minus lambda. 15 minus lambda. If you add all columns together, then first column 1 minus lambda, 2, 3, 4. 15 minus lambda, 5, 1 minus lambda, 2, 3. 15 minus lambda, what you will get? 15 minus lambda, 4, 5, 1 minus lambda, 4, 5, 1 minus lambda, 2. 15 minus lambda, 15 minus lambda, 3, 4, 5, 3, 4, 5, 1 minus lambda. So this can be written as 15 minus lambda can be taken outside, and it can be written as 1, 2, 3, 4, 5. Here 1 minus lambda, 1 minus lambda, 2, 3, 4, 1, 5, 1 minus lambda, 2, 3. Here 1, 4, 5, 1 minus lambda, 2. then 1, 3, 4, 5, 1 minus lambda. That is equal to 15 minus equal to 0. To find characteristic polynomial, we have to equate this equal to 0. This is not equal to 0 because we are going to get another 4 eigenvalues. Let it be 0. Then either this equal to 0 or this equal to 0. This is the meaning. Product of two numbers equal to 0 means either this equal to 0 or this equal to 0 or both equal to 0. Therefore, 15 minus lambda also equal to 0. 15 minus lambda also equal to 0. Also equal to 0. Therefore, lambda equal to 15. We got the one real eigenvalue. Lambda equal to 15. Therefore, the answer is C. Answer is C. C is here. C is here. Answer is C. So, in a matrix, if you add all numbers together, it gives the same value, 15. If you add all these numbers, it gives 15. If you add all these numbers, it gives 15. Same way. And therefore, we can proceed this way to find the sum of all numbers equal to 1. This, if you remember this, you can find that eigenvalue without doing all these things. You can directly write sum of those numbers equal to. Therefore, lambda equal to, the shortcut is lambda equal to sum of rows. If they are equal, sum of rows, sum of rows, sum of sum of not rows, sum of elements in a row, in any row, if all rows have equal sum, if sigma r rows rij equal to sigma r r1j r2j equal to r sigma 3j. So all rows, if equal values have, we can immediately write the sum of the values. No need to do all these calculations. Immediately we can write it is 15 is the answer.